All right, this video is going to help us in using the speed equation. In this case, as far as our equation is concerned, speed and velocity are going to be the same. Now, they have some differences, but when we're calculating both of them, we can use the same equation, v equals d over t. Velocity equals distance divided by time. Let's look at those variables a little bit closer. V. V stands for velocity. Sometimes it's referred to as speed. And the base unit for velocity is meters per second. Now, sometimes that's going to be centimeters per second, it could be miles per hour, but the base metric unit that we're going to use is meters per second. And when they're asking for velocity, they'll say, what is the speed of the car, or how fast is the car traveling? And so those would be indications that we're solving for velocity. The D stands for distance. And the base units for distance are meters. And if they're asking for the distance, they'll say, how far has the car traveled? Or how long has how long is the distance that the car has traveled? And so we could see how far, how long when we're dealing with distances. Then finally, T. T is time, and its base units are seconds. And it'll say, how long has the car been traveling? Or how much time has gone by while the car is traveling? So those are the three variables, V, D, and T. Now, how do we use the equation? Well, you can solve for each of the variables using the equation. Now, if you know the math and the algebra behind it, you can rearrange the equation. We give our students what we like to call the magic triangle, and the magic triangle helps us solve for the different variables in an equation. And so if you fill it in like this, the V, D, and T in the triangle, you can pretty easily solve for the velocity, the distance, or the time. Now, what we tell the kids to do is cover up the variable that you're looking for with the hand. So if it's asking for velocity, we would go ahead and cover up the V. Now I'm just going to have this little hand here to help me out. So if we're looking for velocity, we're going to cover up the V. Now what are we left with? We're left with distance and time. The distance is over the time, so V equals D divided by T. So if it's asking for the velocity, you're going to go distance divided by time. If it's asking for the distance, we cover up the D. And when we cover up the D, we're left with V and T, and they're side by side. So that tells us we're going to multiply. Distance is velocity times time. And finally, if we're looking for the T, we're left with D over V. And so it's distance divided by velocity. So those are the three ways we can rearrange the equation based upon what the problem is asking us for. Let's do an example. Here it says a car travels 10 meters in 4 seconds. How fast is the car traveling? Well, if it says how fast, we know it's going to be V equals. That how fast is tipping us off as to what they're asking for. So V equals what? Well, here's our equation. We can use the triangle. Cover up the V, just like we had on the last page. We know that V equals distance divided by time. We can go ahead and plug that in with our distance being 10 meters and our time being 4 seconds. So we're going to go ahead and put 10 meters and 4 seconds. 10 divided by 4 is 2.5. And since we have meters on top and seconds on the bottom and nothing cancels out, it's 2.5 meters per second. That'll be our first example. Our second example asks for something a little bit different. It says a car travels for 10 seconds with a speed of 5 meters per second. How far did the car travel? So now we're looking for how far. We talked about that earlier. How far is asking for the distance. And if we look at our triangle, we can cover up the distance on top. Once we cover up the distance, we know we're left with D is equal to V times T, because the V and the T are besides each other, and we can multiply them. All right, let's plug them in. So we know our distance is going to be equal to the velocity, which is right here, 5 meters per second, times the time, which is right here, 10 seconds. So if we have 5 times 10, that's going to be 50. And since it's asking for the distance, these seconds are going to actually cancel out. And so we're going to be left with meters. So 50 meters would be our answer for practice problem number 2. The last one, we're going to solve for time now. It says a car traveling at a speed of 50 meters per second covers a distance of 20 meters. How much time did it take for this to happen? How much time? T equals question mark. Time, looking at our equation one last time, we're going to go ahead and we'll take our hand, cover up the time. We're left with D divided by V. All right, look at our problem. Our distance is 20 meters, and our velocity is 50 meters per second. 20 divided by 50 is going to be 0.4. And then if we have time here, we can see that the meters on top and the meters on bottom are going to cancel, and we're left with 0.4 seconds. So we solved for time being 0.4 seconds. So that is the speed equation, the different variables that we're able to look at, the units used with those variables, how we rearrange the equation to help us out, and then 3 practice problems solving for each variable.